Our today's topic is interior of the earth. What is interior of the earth? See, earth is divided into three main layers. The dense, hot inner core, which is yellow in color, the molten outer core, which is orange in color, the mantle, which is red in color, and the thin crust, which is brown in color, which supports all life in the known universe. The internal structure of earth are the layers of the earth, excluding its atmosphere and hydrosphere. To understand this very clearly, let's take an example. See, the example goes like this. Boil half a liter of milk. Okay, when the milk comes to a boil, switch off the gas. Keep a lid on the vessel. After 10 minutes, remove the lid, take it to a side and tilt it. Observe what happens. What can you see on the milk? In what form do you see the layer of matter on the milk? Now remove this layer of matter. Take note of the difference in temperature of this matter and the milk. Now see, before boiling, the milk was in the liquid state, right? After it came to a boil, steam started coming out from it. After some time, a thick layer of cream develops over the milk. The temperature of the cream is lesser than the milk below. Thus, it can be implied that now what does this mean? Thus, it can be implied that the creamy layer cooled faster than the milk below it, which remained hot and in a liquid form. A similar process occurred when the earth cooled. The scientists unanimously believed that the earth was formed out of the solar system itself. Initially, earth was a gaseous hot balloon. It cooled down as it rotated around itself. The process of cooling took place from the outer surface towards the earth's center. As a result, the outer layer, that is the crust of the earth, become cooler and solid, but as we move from the surface to the core, heat increases and at certain depths the interior of the earth is semi-liquid. See, man has always been inquisitive about what lies in the interior of the earth. Inquisitive means curious. Man has always been inquisitive about what lies in the interior of the earth. A direct observation of the earth's interior has not been possible as yet. Through various methods, the scientists have tried to estimate about the same. Matter coming out of volcanic eruptions consists of hot magma, gases, steam, etc. When lava cools and solidifies, igneous rocks are formed. Through the estimates of the study of temperature, density, gravitational force and pressure, the interior of the earth was understood. For instance, when we go deep into a mine, we feel an increase in temperature. Similarly, the magma coming out of volcanoes from the earth's interior is hot. Such estimations were made by the geologists. Several earthquakes occur in various places of the earth every year. These seismic waves are generated. These waves travel through the interior of the earth. The study of their direction and velocity helps us to estimate about the interior of the earth. Man has also tried to dig deep boreholes in the interior to know more about the same. Now, the second part is parts of interior of the earth, or we can say the layers of the interior of the earth. But before that, we should understand the composition of the earth's interior. Our earth was formed approximately 4.6 billion years ago. Initially, the earth was in a gaseous state. It started cooling through the process of radiation. The earth then liquefied. With time, the outermost part of the earth cooled first and became solid. This outermost layer of the earth is called the crust. Even today, outer planets of the solar system are in a gaseous state. Now, after understanding the composition of the earth's interior, let's study the layers or the parts of the interior of the earth. So, the layers or parts of the interior of the earth are divided into three parts. First is crust, second mantle, and third is core. Again, these three parts are subdivided into two parts. The crust is divided into continental crust and oceanic crust. Mantle is divided into upper mantle and lower mantle. Core is divided into outer core and inner core as shown in the diagram. Let's study them one by one. So our first layer or part is crust. Now what is crust? In geology, the crust is the outermost solid shell of a planet, dwarf planet or natural satellite. It is usually distinguished from the underlying mantle by its chemical makeup. However, in the case of icy satellites, it may be distinguished based on its phase, that is solid crust versus liquid mantle. The crust of Earth, Mercury, Venus, Mars, to the Moon and other planetary bodies formed via igneous processes and were later modified by erosion, impact cratering, volcanism and sedimentation. Crust is further divided into oceanic crust and continental crust. The crust is the uppermost layer of the Earth's surface in a solid state and is called the crust. The thickness of the crust is not the same everywhere. On an average, it is 30 to 35 kilometer thick. The thickness of the crust below the continents is from 16 to 45 kilometer, 40 kilometer under the mountain ranges and less than 10 kilometer under the oceans. As we move deeper under the surface, temperature increases. After that, the rate of increase in temperature reduces and again increases in the core. At the center of the earth, the temperature is around 5500 to 6000 degrees Celsius. The crust is the thinnest of all the layers when compared to the mantle and the core. It can be divided into two sublayers, that are the continental crust and the oceanic crust. Now what is oceanic crust and what is continental crust? So oceanic crust. First is the oceanic crust. Oceanic crust is the uppermost layer of the oceanic portion of the tectonic plates. It is composed of the upper oceanic crust with pillow lavas and a dike complex, and the lower oceanic crust composed of proctolite, gabbro and ultramafic cumulates. Oceanic crust is primarily composed of mafic rocks or sima, which is rich in iron and magnesium. Oceanic crust is the second layer of the crust. It is made up of silica and magnesium. It was earlier called sima, as it is rich in iron and magnesium. It is made up of silica and magnesium. It was earlier called sima. The layer is approximately 7 to 10 kilometer thick. The density of this layer is 2.9 gram per cubic centimeter to 3.3 gram per cubic centimeter. In this layer, basalt and gabbro rocks are mainly found. Continental crust. The continents are mainly composed of silica. That is, silica is the compound of silicon elements and aluminium. Because of their higher proportion in this layer, the layer was earlier known as sial. The density of continental crust is 2.65 to 2.90 gram per cubic centimeter. The thickness of this layer is approximately 30 kilometers. Granite rocks are mainly found in this layer. Continental crust is the layer of igneous, metamorphic and sedimentary rocks that forms the geological continents and the areas of shallow seeped close to their shores known as continental shelves. This layer is sometimes called sial because its bulk composition is richer in aluminium silicates AlSi and has a lower density compared to the oceanic crust called sima, which is richer in magnesium silicate MgSi minerals. Second part is mantle. Mantle is a layer of the earth that sits between the crust and the core and is made up of mostly solid material. The mantle is located between the earth's crust and core and is the largest and thickest layer of the geosphere. The mantle is made up of mostly solid material but behaves like a viscous fluid over long geological timescales. The mantle is about 2,900 kilometers, that is 1,802 miles thick. The mantle makes up about 84% of the Earth's total volume. The mantle plays a part in the dynamic nature of Earth's ridged outer layer. Below the crust lies the mantle. Mantle can be divided into two layers, that is upper and lower mantle. The upper layer is more in liquid state. Here one finds magma chambers. It is through these chambers that magma comes out on the Earth's surface during volcanic eruptions. This layer is also known as asthenosphere. Epicenters of deep-seated earthquakes are usually found here. Mantle begins at a depth of around 42 km from the Earth's surface. The internal energy released due to endogenetic movements occurring in the layer is responsible for mountain building, rifts, volcanic eruptions, earthquakes, etc. In this layer, it is inferred that the temperature at a depth of 2400 to 2900 km would be around 2200 degrees Celsius to 2500 degrees Celsius. Here there is a sudden change in the structure and density of material. It is estimated that this layer extends up to a depth of 2870 km. Average density of this layer is 4.5 gram per cubic centimeter and it increases with depth. Increasing pressure is the reason behind this. The density of lower mantle is about 5.7 gram per cubic centimeter. Now the sublayers of mantle are upper mantle and lower mantle. The upper mantle extends from the crust to a depth of about 410 kilometers, that is 255 miles. The upper mantle is mostly solid, but its more malleable regions contribute to tectonic activity. Two parts of the upper mantle are often recognized as distinct regions in Earth's interior: the lithosphere and the asthenosphere. Lower mantle. The lower mantle is the layer of the Earth that's located between the transition zone and the outer core from 660 to 2900 kilometers below the surface. It's made up of silicates that contain magnesium and iron and accounts for about half of the Earth's mass. The lower mantle is the liquid inner layer of the Earth from 400 to 1800 miles below the surface. The third and the last layer of the Earth's interior is the core. The Earth's core is a dense, hot, ball-shaped center made up of iron and nickel. It's located beneath the mantle and the crust and is the planet's hottest part, as hot as the sun's surface. The core is made up of two parts, outer core and the inner core. Earth's core is the very hot, very dense center of our planet. The core starts from around the depth of about 2900 km from the Earth's surface. The part of the Earth's interior extending from the mantle up to the center of the Earth is the core. The thickness of the core is about 3471 km. This layer can be divided into inner core and outer core. The two sublayers of core are inner core and outer core. The outer core. The Earth's outer core is a liquid layer of the Earth's core that is made up of mostly iron and nickel and is located between the mantle and the inner core. Mostly iron and nickel with smaller amounts of silicon and oxygen. The outer core's higher electrical conductivity combined with its turbulent convection allows it to generate the Earth's magnetic field. Outer core extends from around 2900 km to 5100 km. The secondary waves cannot pass through the core. They get absorbed in this region. This had led the scientists to believe that the core could be liquid or semi-liquid in nature. The primary waves travel through this layer, but their speed reduces when passing through this layer. The density of outer core is 9.8 gram per cubic centimeter. The temperature of the liquid outer core is around 5000 degrees Celsius. The difference between the temperatures of the outer core and inner core gives rise to vertical currents. The Earth's rotation gives them eddy, that is circular motion. Electric currents develop in these spiral eddies of liquid iron, and thus magnetic field is generated. It is sometimes called the geodynamo too. This magnetic field of the Earth is functional even outside the Earth's surface for a quite a distance. As a result, a cover develops around the Earth because of the magnetic field. The Earth's atmosphere is protected from solar winds coming from the Sun. The magnetic field thus developed around the Earth is called the magnetosphere. This is the fifth and the important sphere of the Earth. Inner core. Second sublayer of core is inner core. Inner core extends from around 5150 km to the depth of around 6371 km, that is the Earth's center. It is the core of the Earth which is in a solid state. The density of this sphere is around 13.3 gram per cubic centimeter. Iron and nickel are the major elements found here. Therefore, this layer is also called knife. As the materials N-I-F-E knife. As the materials in this layer are under extreme pressure, the inner core is in solid state. The temperature here is the almost equivalent to the surface temperature of the sun. The inner core of the Earth is the innermost layer of the planet and is made up of solid ball of iron and nickel. The inner core is made up of mostly iron 80% and some nickel. The inner core is under intense pressure which keeps it solid despite its high temperature. The innermost part of the Earth is the core and is about 1500 miles, that is 2414 km thick.